Good morning, student. First of all, sorry I'll not be able to be live in this lecture because, as I mentioned in my email, my second shot. So I record this video before I go to my appointment, and let's see what we're gonna cover in this lecture very quickly. I go to the second topic in your textbook. We're talking about the unit step response, and the second part we're gonna talk about the final response or total response when you have RL or RC circuit, but our source, it is not constant. Okay, so let's see the first topic here regarding for the unit step. Generally, when you're talking about the unit step means the signal, it has zero value. At certain point, it jump to the one constant value. So the change two values, 0 or 1. That's the situation. Now, depending about the starting point, that's how I identify the UFT, what to call it UFT. So here's if I have U of t, in that case, here is the T0. So the starting at the point 20. But generally, if talking about the U of t itself, which means the step point in this case will be 0. So this is my U of t equal 1 at 0, and the rest of the t larger than 1 equal 1. So similarly, if we write down the minus of t, so depend about the expression of U of t. Here's U of t, and here's U of minus t. So U of minus t basically is the same shape, but it has a negative side. And here's some practice for the U of t and how I identify the shift of U of t, right, left, how much I'm gonna make that shift. So here's I listed six graphs, and let's start to solve it one by one. So the first one, U of t, as we mentioned, U of t start at 0. So basically, I'm looking for the step point. So here is the t equals 0. That means I go to my domain, and here is the T0, the step point, and end up with the 1 in entire scale. Now, let's jump to that U minus T. So similarly, I find what the minus T equals 0, the entire parentheses, this should be equal 0. That's the way to find the step point. So here is the minus T equals 0. So that means step point will be 0 as well. So we have 0. But in this case, my scale goes to the negative side. So basically, I start with the 1, and my signal will be in the negative side. This is for the T domain. Let's see regarding for the shift. So here is the T minus 5, for example, and here is the T plus 5. How I can identify where the step point. So I know if U of t, it should be 1 in the positive directions. What about minus 5? So similar the way that we did. So you take the quantity inside the parentheses, and in this case is t minus 5 is the quantity, and this one's equal 0. Find the step point at 0. So from here you can find the t equal 5. So that means I have to stop at 5 in the time I 5. So here is the value 5. Here is the t equal 5, and then my unit step will be 1. See, here is the 1. So now let's see for the third one, or the third one for the minus t minus 5. Similar situations. You have t minus t. You find the step point minus t minus 5 equals 0. This one is equal 0. So from here, you can find minus t or t equal minus 5. So what that means, I have to go and find minus 5 point in my scale. Here is the minus 5. And it is minus U of t. So what that means, it should be go that way from minus 5. Okay, this is the second one. Let's go for the fifth one. Same concept. Here is I will take t minus 5 plus 5 equals 0. I found t equal minus 5. So my step point will be minus 5. And here is the plus u of t, means I go to the, here is the 5, and here is the 1. What about minus t minus 5? So the same concept here. What you will find here is the t equal 5 in this case. Will be t equal 5. I go to the t equal 5. And here is the minus t, is not positive t. So which means my unit step could be, it should be in the left side. Here is the 1. So basically that's the way how to draw u of t regarding for the shift, what amount of the shift is, the right or left. Just basically take the quantity inside the parentheses and equal 0 and find with the step point of the time. Okay, so now how we implement or how to use our u of t functions in my electrical circuit. And here is the one thing, we can represent our voltage as a function with u of t. So if you look at that case here, how I can represent my functions, find my p of t here. So the way I will use your textbook mentioned about this case, where is that my curve v will be a when I have less than t0. I have a and b when I have larger than t0. And the way that I will explain it to you, we're gonna use as the previous one, but the only time here I have two quantity. I have this one and have the second one here. Okay. That I have two quantity in my case. So let's start with the A. I'm gonna draw one by one. Here is the A. A means it is independent of the time. So which means I have this value. This is the A. An entire time is not dependent about the time. So that means negative and positive value. The second quantity here is the P U of T minus T0. Where is the T0? You can assume any value. T is minus T0. If you look at remember the previous slide, when I have U T minus T0, my step point will be T0. Here is the T0. What else? And I have here, it should be 1. 1, this quantity multiplied by B. So what that mean? It means it should be like this. My signal or my unit step here, it is not gonna be 1 because multiplied by B, it will be B. Now basically what you will do, V of T, just you add those two quantities together. What you end up from the T minus or T less than 0 in this area here, I have the only A. So I have the A here. Okay. What I have in the second side, let's draw it in the good way. So in that way here, my signal started at t equals 0. So which means this one t0. Before t0, my quantity will be just A. So the t minus 0, here is my V of t will be A. Once we hit the t equals 0 here, I have two quantity. I have A plus this part here, which should be B. So my signal will be that shape. Where's this point here? A plus B. So if you want to write it down as the equations, it is exactly the same thing that we mentioned here that way. I have V of t, A, t less than t0 is my starting point. So let's, if I change the color to draw my final signal, it would be good. So here is my final signal. This part here. And this part here. This is my V of t right now. So what I have A less than t0, and I have A and B when I have larger than t0. It doesn't matter what those value is, positive, negative, large, small, it doesn't make any difference. You can assume any value for A and B, you can assume any value for t0. That doesn't make any difference for the shape, for the shape of your output. Another thing that we can use to make or to generate a pulse based in u of t. So here is the u of t, and they are listed as a pulse based in that case. So what we can do, we can formulate or we can generate that pulse based on the play of u of t. So just to be easy for you, let's assume t1, this is my large pulse, t1 equal, let's assume 4, and t0, let's assume it is 2, just to make it numerical one easy to imagine. So generally you can use the same concept for any t, but now just you can imagine it in an easy way. Now what I will do, I can generate my unit step functions start from the t of 0. What that mean? I have u of t minus t0, and that one it should be, because my magnitude is 1, but here's my magnitude is vo, so this one should be multiplied by vo. When I draw it, I start from the t0, I go to the vo, and this is the shape. The second part, here's another pulse, start from the t1, so in this case our t1, t0, assume it is 2, so we can put it as 2 here. Another pulse starts from the 1 or the t1, or in this case is 4, so that means my starting point will be at 4. But look at the magnitude, vo as well. But here is the t1. Let's draw it in the scale. Let's add it here. It's the t1, which in this case equal 4. But in this case, imagine guys, if I multiply it by vo, I end up with the positive pulse, like this shape. Okay, when I add it together, it's gonna be increased my signals. It's not gonna generate the pulse. So what that means, I need to multiply by -1 minus vo, in fact. So if I take it -1, it just flip the pulse. And this one will be 1, just multiply by vo. So in this case, here it will be minus vo. And my signal here, it should be minus vo u of t minus t1. Now, if I add those two signals together, 1 and 2, I will end up with the pulse that I expected. So will be 0 less than t0. Then at t0, start with the first one, and I still have 0 here. And once you hit up to the t2 or t1, which in this case equal 4, after that we have negative vo plus vo. They're gonna cancel each other. So I end up with my pulse like this. vo, base it in the adding those two components together as a one signal. That's how to use the u of t. So similarly, that case, if you have two sources, so that's as a previous example, as I mentioned here, just the only thing you add them together, here should be minus. So that's the value that I listed last time. And here's the only difference here. I mentioned here, you add them together, as you multiply by minus, and that one here, you just multiply by minus and subtract it, not add it. It's the same concept. So if you draw this one u of t, but you subtract, you end up with the same result. I'll stop recording this video, and the next video we'll see how we use the u of t to solve an electric circuit.